Hello, we are Capstone Group 16 from Iowa State University within the Industrial and Manufacturing Systems Engineering Department in the spring of 2021. We had the honors of working with Winnebago, and the title of our project was the MacroOps project. Our group had two project objectives. The first objective was to propose a suitable location for the new thermoforming machine that Winnebago will be purchasing at the end of 2021. The second objective is to create a tool to standardize the scheduling process that will include the new thermoforming machine, with hopes to decrease the average setup time by 10% per machine. There were three different categories that went into our current state analysis. The first was the current layout, the second was the current setup factors, and the third was the current scheduling factors. Within the current layout, there were four different methods we used. The first was a hands-on tour. The second was gaining employee perspective. The third was a motion study, as you can see in the picture there. And the fourth was taking specific measurements within the plant. In the current setup factors, we had two different methods we used. The first was a process analysis, and the second was gaining operator perspective. As you can see in the photo provided in the right, there is the average setup time per machine, which we in the end hope to decrease. And last was the current scheduling factors. Within that, we had three different methods. The first was the 5 whys, the second was a fishbone diagram, as you can see provided there in the photo, and then the last was gaining operator perspective.
For the first objective, our group came up with a solution that includes 3 future state layouts. One for the 6 months, one for 2 years, and one for 5 years. This allows them to visualize a plan and have an end goal for the future of their plant. The 5-year layout is not pictured in this slide. The image on the left is the current state, followed by the 6-month and the 2-year layout. The 6-month layout is a picture of an adjusted current state map that our group did. We adjusted it so that the company can also adjust our layout based on unseen factors that may arise during the installation process, and the company can adjust accordingly. The 2-year layout with an old machine being taken out of the plant is on the far right. As you see, not much has changed. This layout is focused on improving process flow and making sure that things are in place so that the company can increase efficiency and output in the future.
Another major deliverable from us to Winnebago is what we call the master schedule. The master schedule is essentially an Excel workbook that Winnebago can use to create an easy-to-read line balancing tool. It takes input from Winnebago and the user to pull from a database and organize the machine's schedules for the day. We believe that using input from this program, Winnebago will be able to reduce their scrap by about 10% each year. This will be done by providing recommendations to send the right orders to the right machines so that there is less error. Additionally, we think it will provide some consistency in between production managers should the main one ever need to be out for a week or so.
As we dove headfirst into this project, we were focused on creating realistic solutions that Winnebago could actually use, something that would affect their day-to-day output. We saw that our first solution increased the plant utilization by 6%, which we thought could balance out the increase in indirect cost. We also looked to lower scrap and average setup time by 10%. This also had an effect in lowering the overtime hours, which averaged about 5 hours per employee currently. As you can see on this financial impact chart, we'll start with the scrap reduction. In 2 sectors, we look to lower scrap and will lower scrap by 5%. This will come out to be an almost $5,000 yearly savings. For setup reduction, we lowered the average setup time by 10% for each machine. Adding this all up on a yearly basis, we looked at saving about $17,500. Add these both together, and we're looking at a monetary value of just over $22,000 saved yearly by these realistic solutions that we have produced. We truly enjoyed working with Winnebago, and we hope these solutions can affect them in the way that we feel they could.